This is the CNC Router Tips Podcast, episode 54.
Our customers then were guys in their garage, entrepreneurs, people that had an idea and wanted to build something, small shops that were using all manual machines and couldn't afford the big expensive CNC machines, and they would convert them to CNC. Well, they would use Centroid products. We sold to the do-it-yourself or a startup and small shop.
This is the CNC Router Tips Podcast, a show which answers one question from you, the listener, about CNC router tables, CNC software, hardware, web hosting, and business. I'll help you get started in your CNC hobby or business and help you cut through the confusion.
Today's episode is sponsored by themakersguide.com. The Maker's Guide. Useful tools for makers.
Hello, everyone, and welcome to another episode of CNC Router Tips Podcast. I'm your host, Bill Griggs, and I'm very glad that you could join us today. We have a special guest with us today that has some interesting stuff to tell you about himself and about the new technology that he and his company have been working on, and I'm really excited for you to hear about this. As some of you may know, in our private Facebook group, hashtag CNC Router Tips Facebook group, we just reached 10,000 members a few days ago, and we had a very nice response to that fact. Folks were sending congratulations all around and talking about how they remembered being in the group when it first started. It's been a very quick rise, and it's very rewarding and enjoyable that we've reached that level of participation. And so I hope that this episode will help some of the guys who are in that group with some new projects, because the stuff that Keith McCulloch, my special guest today, has to talk about will be of interest to you in that group and to the CNC community in general. So without further ado, I'd like to welcome my guest, Keith McCulloch. How are you doing today, Keith?
I'm doing pretty good. Hey, Bill, it's great to be here with you.
Fantastic. Now, I came to know about you a little bit at first on YouTube, where I saw some of the videos that you had put out over the years. How long have you been doing YouTube videos?
Wow. Actually, I started out making videos on Betamax, CNC videos.
That's a while ago. That kind of dates it. Yeah.
Yeah, it's been a long time, for sure. And YouTube's obviously a great thing. And when that came out to facilitate me being able to put CNC videos out on the web in a quick, easy way. I mean, even before that, I was embedding Windows media files that were, 360 by 240 on the web, and really happy that YouTube's come around and be able to share the knowledge and the technology with everybody out there.
Oh, fantastic. Now, your major focus has not necessarily been on CNC routers, but it has all been CNC related in most of the things that I saw. In fact, your nickname online is CNCKeith. So, that's really cool. Now, tell the folks where you're from and a little bit about yourself.
Sure. Grew up in central Pennsylvania, went to Penn State University, went through the mechanical engineering program there, ended up working for Centroid through college, and then got out of college and thought, well, I'll just, this is a lot of fun. I'll stick with these guys, and I've been there ever since. Centroid was actually originally located right in State College, Pennsylvania, and moved through a number of different buildings in that area as they grew. And about 15 years ago or so, they moved outside of State College, about 18 miles outside, to get a bigger building and more room and closer to I-80, so they can get machine tools in and out of the building with trucks easier. So now,
many of our listeners may not be familiar with Centroid. Centroid started out as a company that was making retrofit kits for CNC machinery. Is that correct?
Yeah, even before that, I can give you a brief history. In 1979, Centroid was started by two guys that were just general purpose computer consulting guys. And one of their first jobs was to automate some laboratory equipment. So they invented a motion control system to do exactly that. And so they put together some stepper motor drives that they had developed themselves, and a CPU, a dedicated CPU, and put it all in a box. And it was called the Big Stepper. And the Big Stepper allowed you to control 4 stepper motors, and the language to control the motion was BASIC. So you would program BASIC, and that way you could automate factory equipment, industrial equipment, and lab equipment is what they were working on. Fast forward a few years, a customer came to them and said, hey, you got all this great motion control stuff, but I'd like to put it on a milling machine. And all previous milling machines at that point, they used G code. You guys think you could make it so it would run on G code? So the Centroid guys developed a user interface that would accept G code as motion control commands, and the CNC2 was born, a box that had 4 stepper motor drives in it and a CPU that connected to a teletext monitor. Mm-hmm. And so it was a standalone unit that, and one of the first things they did was bolt that with some big 1350 ounce-inch stepper motors on our Bridgeport milling machine, and that's how Centroid got into CNC. That was in 1982.
Yeah, that's good. I was about to ask you that. So this has been in development for quite a while. I remember learning BASIC back in the late 70s. It was the go-to computer language for people who were getting started in programming, and then things got more sophisticated. So it's very interesting that you would transition from BASIC to G code. Now, with all of this going on, how did you get involved in CNC initially? What was your first exposure to CNC?
Me personally?
Sure.
Yeah, working at Centroid. Started out, they had some Bridgeport machine tools that just came off the truck, and they were all greasy and messy with old Tektronix controls that were the size of refrigerator boxes. And they said, Keith, go out back and strip all that stuff off and start cleaning those machines. And what they were doing is prepping them to install brand new CNC controls on them and turn around and sell them. So that was my first exposure. And then later on in the shop, I started using the Centroid CNC controls were on their own machine tools, obviously, in their shop. So they would be making parts for retrofits and even parts for their own manufacturing process and to make the control itself. So they actually had Centroid CNC controls installed on machines making parts for other Centroid CNC controls. And so I began programming and using the machines in the shop, and that's how I got into CNC.
Well, let's go back just a little bit further. What was what were you interested in before you got into working with Centroid? What were you doing that earned you the job? And tell us a little bit about your background.
Yeah, well, as I was really into cars actually through college. I put myself through college by buying, fixing, and reselling cars. A lot of my buddies would get jobs at like the pizza place, and I saw an opportunity to just buy an old beat up car and fix it and sell it. So I was interested in things mechanical. I was interested in fixing things. And that always leads to, hey, I need a hole in a piece of metal, or I need to change something, build something, and that leads you to a machine shop. And then at the machine shop, you learn about manual mills, and then you discover, oh, wow, they got these computer-operated ones. That's awesome. Mm-hmm. And so that's kind of was the background and how I got there and got the job and the way I went.
Okay. So when you started your relationship with Centroid, they had already gotten into the conversion portion of it. They had already, they were already doing the Bridgeport retrofits and that sort of thing. Now, as you know, our show is made up of listeners who primarily have CNC router tables. Did there ever come a time when any Centroid controllers were being used on router tables?
Absolutely, it was a natural fit for sure. And on the retrofits, just want to mention there's really two different types of retrofits. There were actually manual to CNC conversions that were going on, where you would actually take a manual Bridgeport machine and install ball screws and motor mounts. And then there were also taking the old Boss series machines that were already CNC to begin with, and just installing new CNC control systems on it. It's a natural thing, because once you have a CNC control for a milling machine, it is just a very short step to put that exact same CNC control on a router. Things are not much different at that point. Mm-hmm. One of the router-specific features early on that was developed was axis pairing, so that you could have two motors paired, for instance, on a gantry router, where you have two stepper or servo motors moving that gantry on either side. So that was an important feature to be able to add. I mean, occasionally you run into that on a milling machine, but it's quite rare. Usually it's a big bridge mill, which just kind of looks like a big router anyways. But my interest in routers came early on as well. There was several OEMs early on that used the Centroid CNC Control on their router systems. Forest Scientific, Magnum was some early router customers, where they were doing custom-built routers for both industry and education, and they used Centroid CNC controls. And as the word got out, people with older routers, or routers that had cumbersome CNC controls or expensive to repair, would come to us and look for an affordable solution to be able to put a new CNC control on the router, because mechanically it was still in great shape, so it was worth it to upgrade the electronics on it to get new features and performance and reliability out of the system. So for many, many years, Centroid CNC controls have been installed on a wide variety of routers, both as new and retrofit applications.
My first exposure to your company and the controller, I used to do some work for a local company that owned a Onsrud CNC router with two. It had 4x8 size, and it had two separate tables. Each one was 4x4 on it, and had a very old controller system on it that was proprietary. It was very. It had a built-in memory, so you could only load a few lines of G code into it before it was full, and had to drip feed the content to it. So, we decided that it was time to upgrade, and when we looked around, we discovered the Centroid system, the all-in-one system. I think it was the one that we looked at, and we had someone from Centroid come out and give us an estimate on what it would cost to have that done, and then they went ahead and they put that on that machine, and it gave it the opportunity to run again. More efficiently. We had to learn a different software, but that was about it. And the memory limitation was gone. So that's how that Centroid came to on my radar a few years ago.
Nice, yeah. The all-in-one DC has been one of our most popular products over the years. On that board, that we combined the PLC, the motion control, and the servo drives and spindle control all onto one board, just for retrofit applications to simplify the installation process. Mm-hmm. And that's That's a great setup, and that's a story I've heard 1,000 times. I mean, all the old the Morbidellis, the Onsrudes, the standard routers, the multicams, just right down the line, Northwood. There's just a bunch of great routers out there that mechanically they're still in great shape, but computers and controls get old quick, and so they'll often not last as long as the mechanical. So here we have the ability to often reuse a lot of the existing components that came with those machines to both save money and simplify the retrofit installation.
Yeah, in the case of the Onsrud machine that we had, as part of the upgrade, we actually ended up needing to replace the servos and drivers as well. So that it became a little bit more of an expensive proposition than if we had tried to use the existing servos that were there. In either case, we could have probably done it. But, it was decided since we were upgrading things, we might as well go with the latest, greatest. And I don't remember what the total cost of the upgrade was, but it was somewhere between $5,000 and $10,000. I don't think it was. I don't think it was towards the high end. But the point was, we were replacing very large servo drives and very large servo motors, which ate up a good portion of the budget versus the controller. The controller was I think a few grand at the time. So it wasn't, it wasn't outrageous, but when you consider that machine had probably cost over $100,000 when it was new, that's just a drop in the bucket. So, when we're talking numbers like those to the vast majority of my audience who are home CNC guys, that's like way above their price level. So I got excited a little while ago when I was browsing the web, and I don't remember how exactly this came to my attention, but it all happened inside of a day, maybe 3 weeks ago, where I stumbled across a new product that Centroid put out that I think is particularly cool, solves a niche, solves several problems at once, and it's very rare for me to make a spontaneous purchase. Because I'm not the richest guy in the world, and I'm kind of cheap. But when I saw this product, I went out and grabbed up my credit card and ordered one. And because it does so many things. So let's talk about that product. I know I did a Facebook Live video when I got the product and unboxed it for the folks in the group, but some of you may have missed that, and not everyone who listens to this podcast is also in my group. So let's talk about the Centroid Acorn.
Yeah, that's a really exciting product that I've had a lot of personal involvement with, and the idea was spawned actually about 3 years ago, and we started working on it earnestly about 2 years ago. What it is in a nutshell is Centroid is re-entering the do-it-yourself CNC control market that we left so many years ago with the Acorn CNC Controller. It's a little 4-axis CNC controller that runs the exact same software that you'll find on the M400 and T400, our high-end CNC controls that you find on, $300,000 machine tools. Mm-hmm. Except this little unit is an open loop unit. That's the big difference between our other CNC control boards. The other boards are the all-in-one DC and the Oak board, which are true closed loop, where the encoder feedback from the servo motors is actually being fed back into the CNC control board, not just back to the drives of the motors. And then the control software is looking at that at all times and making decisions based on that information.
So essentially, a closed loop system has two areas that check to make sure that the servo got where it was going, where you told it to go, and verifying it?
Exactly. You'll have encoder feedback to the drive and also encoder feedback to the motion control board and software. And with an Acorn, you can have a hybrid closed loop system where the servo motors like Yaskawa, Delta, Clearpath, those guys, they have encoders. They feed back to the drive that's driving that servo motor, but that encoder feedback for the axis motors does not come into the Acorn board or the CNC 12 Centroid software. Hence, it's called an open loop system or a hybrid if you're using those particular types of motors. That's how we're able to have the price point that we're at, and this is an entry-level system. It performs remarkably well. Our first test bed machine, we had a 40 by 20 bed mill that we hooked an Acorn up, and we put 3 different types of AC brushless servo motors on each drive. We had some Deltas, Yaskawa, and Estuns, different motors on each axis as a test mule, and we were pleasantly surprised at the performance that we were achieving out of this machine tool that rivals closed loop systems. So when we put the ball bar on it and ran the tests, it's pretty stunning, the results that you can get with a hybrid setup and the Acorn, a hybrid servo motor setup with the Acorn CNC control board.
Back up for a second now. Explain to the listeners in quick layman's terms what a ball bar is, in case they were wondering.
Yeah, a ball bar is a very accurate measuring device that you put on a CNC machine tool. It could be a router, mill, lathe, it doesn't matter. And it measures actual machine tool, the table movement relative to the spindle. And what you do is you simply program a circle with the CNC control, and you connect the ball bar up. One end goes in the spindle, and the other end goes on the table. And you command a 2-axis circle. On a milling machine, it would be an X and Y. And you run it at various speeds. And the ball bar is connected up to a laptop, which is running some software that's reading the signals from the mechanical device, and then plots that out on a graph. So if things were perfect, you would have a perfect circle. And if things aren't perfect, it shows you what the machine is actually doing compared to what you're commanding. And it's the industry standard way to measure and qualify a CNC machine tool. And so we use that, of course, on all the machines that get controls installed in our shop. They all get ball barred before they go out the door, and there's a record kept and all that kind of good stuff. Well, we put the ball bar on this test mule bed mill with the Acorn, and you were hard-pressed to find the difference between the plot on the Acorn and compared to the high-end closed-loop system. It was that close. It was amazing. And so super excited about the performance of it and the price point that we're able to offer the do-it-yourself customers. But more excited than anything that I am that we're re-entering this market that we left so long ago. I mean, Centroid started when I told you the story about how in '82 we came up with the CNC2. Our customers then were guys in their garage, entrepreneurs, people that had an idea and wanted to build something, small shops that were using all manual machines and couldn't afford the big expensive CNC machines, and they would convert them to CNC. Well, they would use Centroid products. We sold to the do-it-yourself or startup and small shop companies and businesses. That's where we came from. And what happened through the 90s as we began to add more and more features and more capabilities and more axes is the price went up, and we entered into the industrial CNC market, and we kind of left the do-it-yourself guys market there, and we didn't have a product to offer to those guys anymore. And for years then, we sold through a dealer network where the dealers would add added value service. They, just like the dealer that you described with your router, you would come in and install the product, configure the product, configure the Centroid CNC Control, give you some training, make sure it was a success. And it's a great model to use, but it's not cheap. And for companies that are actually making products and making money in high volume, it's worth it for them because they're up and running fast. They're making money with that machine tool in a short period of time, and it's worth it to spend the money. And over the years, I always had a soft spot for the do-it-yourself guys because I was one myself. I've got a router here, the home-built router in my shop. I've got an old Bridgeport Boss. I've got a flatbed lathe. And I'm just like you, Bill. I'm kind of cheap, so I wanted the performance of the Centroid Control, that industrial quality and performance, but I wanted in it a package that I could afford, and so that's where the idea of the Acorn came from, and we wanted to re-enter that market with this product, and we spent a long time, like a year and a half, in beta test mode, both with the hardware and the software, because I didn't want to release it without it being right and just really working well, like what Centroid is known for. Mm-hmm. And so there was a lot of chatter on CNC Zone. When will Acorn release was the title of the one post, and I think it's like 10 pages long now, and kind of documenting the history of how Acorn was going along. And I teamed up with a bunch of beta testers that we released early hardware and software to that installed it on a wide variety of machines, from little baby benchtop milling machines, routers, and lathes. So incredible feedback from that team, and being able to tweak things and just make things really nice and smooth and easy to configure. Mm-hmm. Go ahead.
I was just going to mention, I mentioned earlier the all-in-one controller, and I tend to give my audience some perspective on pricing. If you got the bare bones all-in-one controller, that was about $3,000 before you added servos or drives or anything, if I'm not mistaken.
The all-in-one actually has 3 servo drives built into it, so that's why the price is where it's at. And the all-in-one DC is $2,249 right now as of this date. Mm-hmm. And the reason why that price is there, it's even more expensive than our oak board. And the oak board's a little more powerful, has more capabilities to it. But the reason why the all-in-one DC is pricier is because it actually has 3 DC servo drives built right into the board, which can handle up to 15 amps continuous per axis. Mm-hmm. But if you start pricing out buying individual components, you're actually ahead of the game with the all-in-one DC. So if you went and bought a PLC, 3 servo drives, a motion control CPU, some analog boards, and started cobbling all that together, you would be beyond that $2,249 price point. And that's why it's one of our most popular products right now.
Mm-hmm. So you then began development on the Oak, which is your modernized, newer version, basically, of the all-in-one, without the drivers, but with other functionality, like, a lower price point on that as well.
Yeah, actually the Oak spawned from some earlier products called the MP11 and GPIO4. And what those were, the MP11 was just a pure motion control card, and the GPIO4 was just a pure I/O card. And the Oak came from joining those two cards together. And through the 90s, our motion control card would plug into the motherboard of a PC. So we started out with ISA slots, and then as ISA died, we went to PCI slots. And then it's been a while now. I think we're up about 6 years ago. We made the move to Ethernet, so that the motion control card now communicates with the PC through an Ethernet connection, is not physically plugged into the motherboard of the CNC PC. And so the Oak board came from combining that MP11 and GPIO4 boards into one board, kind of like the same theme as the all-in-one DC. Well, if we can get all these components onto one board, that means it's easier to install. There's less components, less cables, less wiring, less power supplies, because it's all on one board. The big difference between the all-in-one DC and the Oak board is the all-in-one DC, as the name implies, is made for DC servo motors, and the Oak board is made for AC brushless servo motors. Mm-hmm. So the decision point is if you want to go with AC brushless motors, then the Oak board is for you, or the Acorn board, because the Acorn can also run AC brushless motors.
Mm-hmm. Yeah, I was trying to give the listeners a little perspective and the cost. Now, what excited me, having basic rudimentary knowledge of what the Centroid price points were for the all-in-one DC controller. When the Acorn came out, it was roughly a tenth of the cost of that, and had most of the features that I would want as a do-it-yourselfer already there. So, I looked at this and I said, okay, there's an Ethernet-based motion control card built in. Okay. There's software to drive the motors built in. So it would replace Linux CNC or Mach 3 or UCCNC. It does that functionality. It's built in. There's a power supply that comes with it to power the thing. All right. All of this, and we're talking about 250, what is it, 259, something like that?
265. 265. The introductory price.
Yeah, for the Acorn. So, to me, when I looked at, just from the logic standpoint, let's take, again, I try and inform my listeners in comparison things. If I were to buy Mach 3 or Mach 4, let's use Mach 3 as an example because that is most people in the market. That's a $175 retail purchase for the software. If I wanted to get a smooth stepper or a UC100, I'm going to spend between $100 and $175 for the motion control card, in addition to the $175 I've already spent on Mach 3. So, then I'm going to have to get a breakout board, anywhere from eBay cheap, $10 to $150 for a C32, which is a really nice board. Okay, and then I still have to get something to control the encoders. Let's see, a few other things. So I started doing the math, and I realized that your price point is a fantastic value, and I got out my credit card and I bought one myself. Now, I didn't actually have a use for this board at the time I bought it, but I'm sure I will at the end. And it was just intriguing to me, and I like to keep abreast of the things that are, new and exciting. So, that's my take on, on this board. Please give me yours.
Yeah, I recognize the daunting task that a do-it-yourself CNC control builder has by buying software from one source, hardware from another, sometimes even drivers from yet somebody else, and getting all that to communicate and work together is certainly possible. It's many people obviously have done it and are successful at it. But it's a job and it's a chore, and I wanted to just make it easier. And I made it easier by creating a piece of hardware and a piece of software that was designed to work together from day one and is based on industrial quality hardware and software from existing CNC control systems that we just, changed a little and got that price point down so that the do-it-yourself guys can afford to get something that is simple to install and is one source responsibility, where you don't have anybody. If you have a problem, what happens? You read the forums, people start pointing fingers. Well, that could be the hardware or this, or this could, your problem could be this, and things aren't communicating. Well, I just wanted to solve all those issues and just make it so that it just works and is simple to install. And most people want to get down to making parts. It's fun building and control, but you want to build that, and the goal is to get the machine running to be making parts.
Yeah.
And that's what I created the Acorn for. And The 265 price we're mentioning, I just want to mention, comes with the free version of the Centroid CNC 12 software. And there are two other levels. There's the Pro version and the Ultimate version. And the free version, a lot of people will be perfectly happy with that, certainly educational type situations, installations. But I think most guys are going to want to spend the $99 for the Centroid Pro software. So a fair comparison then to the example that you cited would be add the 265 plus the 99 together so that you have the Pro level Centroid software combined with the Acorn board. And you know, what the Ultimate really gives you, the Ultimate software level, is features that don't even exist at the DIY level on other systems. I took a lot of Centroid's high-end features that they've been known for years and bundled it all together into that Ultimate software level, such as 3D digitizing, 2D digitizing, all menu-driven. You don't have to write any macros for this. The stuff's already in there. It just works. You hook up a probe and away you go. A full suite of menu-driven probing cycles. And y'all can go online and check out. I've got it all listed there on the website. But I just wanted to mention that there are different levels of software. And most guys will end up using the Pro version of the software.
Okay. Let's talk for a minute about what's on the board.
Today's episode is sponsored by The Maker's Guide, creator of the Triple Edge Finder. Get the edge you need, save time and frustration on your CNC project, and make setup a snap. Save time and material. Set up your workpiece on your CNC router table faster than ever. Accurately set your Z-axis height first time, every time. Automatically locate the corner or edge of a workpiece. Reset your starting point in the middle of a program. Quality crafted right here in the USA on US-made CNC machines. Get the edge you need today. Go to www.themakersguide.com/edge. The Maker's Guide. Useful tools for makers.
Let's talk for a minute about what's on the board. Now, I know this might get technical for some, but we're gonna try and not dumb it down, but keep it at a level that is really simple to understand. So I mentioned earlier a motion control card, and a motion control card is what actually sends the signals to and from the stepper motors or the servos. And in this case, the Acorn can do steppers or servos depending on what you hook up to it. I know I didn't make that clear earlier.
Yeah, this is a really important part. This is what differentiates the Acorn board from a lot of other breakout boards. The Acorn board is much more than a breakout board because it has its own motion control CPU built right into the board. It actually plugs right into it. And that, just like you said, is doing all the critical motion control calculations. The Centroid Acorn board is not using the CPU that is in the PC to do motion control. And so what this means is we're not relying on a Windows PC to do all the critical motion control calculations, so that when Windows decides to take over your hard drive or your CPU time to do something, it does not affect the control in any way. So the Acorn CNC controller has its own motion control. All that Ethernet connection is doing is feeding commands down to in a buffered state. So then the motion controller takes care of everything from there.
Mm-hmm. So you enter your G-code or your program on the PC. It gets sent over the Ethernet cable into the motion control card, and then it does everything from there. You don't have to worry. It's just sitting there doing its thing.
Exactly.
Yep. Now, the other thing, now there's a place to plug in your servo motors if you're using them, like the Clearpath Servo motors that everybody's hot about. They're hybrid servo motors, or stepper motors can be plugged into there. So, for example, if you were taking a router table that you already owned and you're upgrading, and let's say that you had Gecko drives in there or something like that, like a G540. Most people who listen to this would know what that is. Mm-hmm. You could plug that G540 directly into the parallel port that is on this Acorn board and be up and running.
Yeah, that's another cool thing. I recognized early on that a lot of users are being kind of stuck with DB25 connections, and they're having a hard time finding PCs that have parallel ports anymore. And so I thought, well, it would be great to have a parallel port on the Acorn board as legacy support for all those old systems out there that use a parallel cable to plug into a PC. And so we put the DB25 on there, even though that kind of looks like, oh, well, that's old tech. Well, it's old tech for a good reason. It now allows thousands and thousands of installations out there that use that parallel cable that are having a hard time finding PCs and keeping their system running. Well, now they can buy a brand new Windows 10 PC and an Acorn board, plug their PC into the Acorn board with the Ethernet, but then plug their system, whether it's a G540 or other breakout boards, into the parallel cable and command it with the Acorn board, which is pretty cool.
Mm-hmm. Now, as far as inputs and outputs go, you can put in limit switches and homing switches onto this thing. It's got ports for that. The part that is interesting as well, I mean, you've got eight inputs that you can use on this board. So you can control 8 different devices, and including touch probes, etc., like my triple edge finder. Mm-hmm. So you plug that in, and it's already got the routines in there to use that, so folks can find X, Y, and Z. It also has outputs for other devices like vacuum pumps or coolant, or your dust collector to turn that off or on, or an automatic oiler, that sort of thing. So you could plug those things in. There's spots for it right on the board, including, if I'm not mistaken, some relays built into the board. Is that correct?
Yeah, we have 8 optically isolated inputs and 8 outputs. 2 of the outputs are relay outputs. The other 6 are open collector, which can be then used. There's some really nice relay boards on eBay. You can buy a 6 relay board on eBay, I think, for under $40, and then connect right up to the header there on the Acorn board. And then, of course, you can drive, contactors or other larger relays that will start large motors like vacuum hold down or dust collection, that sort of thing. It's interesting to note that all those inputs and outputs on the Acorn board are user configurable with a simple piece of software we call the CNC Wizard that has a really nice drop-down menu. So if you wanted input 1 for a homing switch, you just simply select that. There's just a drop-down menu. You're on input 1. You set it to X-axis home switch, and you're done. That's all you got to do. Same with the outputs. If you wanted output 3 to be your vacuum on and off, you simply select that out of the drop-down menu and hit OK and save it. And now all of a sudden, output 3 is turning on and off your vacuum pump.
Mm-hmm. That to me is something that's very useful. It's quick, easy. When you're setting up things, it doesn't take a lot of thought power to do it, and that's always a good thing. Let's talk about the motors and encoders. 2 separate items, but a lot of the CNC routers that we use a regular off-the-shelf woodworking router for a motor, but a lot of other ones use high-speed spindles with a variable frequency drive.
Yep.
We've got the facility in this to plug directly into your variable frequency drive and control that?
Absolutely. Yep. There's analog out, 0 to 10, analog out, which is the most common form of analog out to control a VFD. All modern VFDs take that type of signals. It's just 0 to 10, so 0 volts, that's no RPM, and 10 volts, that's maximum RPM of whatever you set up in that inverter. So that gets you true programmable spindle speed. So right in your G code, when you say M3, which is spindle on clockwise, and then S10,000, the inverter knows, okay, I need to spin my spindle motor at 10,000 RPM. And the little relays on there and the other inputs and outputs can be used more sophisticated. You can hook up, and we have schematics showing all these connections that I'm describing that you can download right off our website. Things like if the inverter issues a fault or alarm code, you can actually pipe that signal back into the Acorn so that the Centroid CNC 12 software would know, hey, the inverter for some reason just issued a fault, I better stop. You know, things like that. That's all those sort of facilities are there.
So with the variable frequency drive, you would be able to control the on and off, the speed and direction?
Yes.
All without doing anything other than hooking up 2 wires?
Well, 2 wires is just the analog out, and then the direction is controlled by one of the relays. So the relay will tell the VFD by opening or closing a contact whether to go forward or reverse. Okay. And then you have another wire, if you want to. Most guys end up doing this. It's not required. Another wire that runs back from the VFD into one of our inputs, and that's the fault signal. So that if that VFD ever stalled for some reason, we would know it, okay? And we wouldn't just keep on going. We would issue an e-stop condition at that point and all stop if the VFD told us, hey, something's up, you know.
Okay. And the last thing that, I'd like to bring up about this board is it has an encoder input. And what will we use that for?
Okay.
And what will it allow us to do?
Yeah, the encoder is a beautiful thing on the Acorn board. It allows us to not only display true RPM as soon as you hook an encoder up, right on the screen. When you turn the spindle either with your hand or turn it on, it'll tell you the RPM right on the screen. So that's great and all, but really the power of the encoder gets us the ability to do things like rigid tapping. And on a lathe, the encoder gets us the ability to do multi-pass single point threading and also rigid tapping on a lathe.
So the main advantage for someone on a router would be to have an encoder on the spindle motor to know exactly how fast it's going, not just how fast you thought it was going.
Exactly, yeah.
Okay.
And then when you program, hey, I want to spin 9,600 RPM, it goes exactly 9,600 RPM.
So all that is built in. It's sitting right there. So I mean, this is a killer. What can't this board do?
It is a 4-axis CNC control board, so it will only control up to 4 axes. It can pair any axis with another axis, with the 4th axis, excuse me. The 4th axis can be paired with any other axis, which is a real popular feature we mentioned before, for especially with gantry routers where they have 2 motors. The I/O at this point with 8 in, 8 out, you can do rack mount style tool changers, but if you start to have very complex tool changers like carousel tool changers that have many inputs and outputs, you might be starting to run out of inputs and outputs. We know that, and we're working on a facility to be able to add additional inputs and outputs to the Acorn board in the future. Okay. But right now, I think with most of your listeners, 8 in and 8 out, you can get pretty creative on how you use the inputs and outputs. And we do have guys that are hooking them up with limit switches and vacuum pumps and all that good stuff, and rack mount tool changers, just with the Acorn board the way that it is.
Now, I know with the encoder and, speaking of tool changing, some of the industrial machines, let's say a Haas or, Moriseki or whatever, they have a tool holder that has to be in a certain orientation in order to be loaded again, because there's studs on the bottom of the spindle nose, and an encoder would allow them to monitor that position as well. Yeah. So then the limiting factor comes in is how many other inputs and outputs you have with that tool changers.
Right.
Correct. Yeah. So
exactly.
Yeah. So that's kind of why I think the Acorn is an exciting piece of hardware, to come on the market for the price point. Even when you add in, an extra $100 for the Pro software, you're still looking at about $360 for that functionality, and it's kind of a plug and play solution for a lot of things. And that's why I got excited about it. That's why I wanted you to come on and talk about it, because I knew it was a new thing that those who like to build might be interested in hearing about.
It's interesting to note in the free version of the software, one of the reasons for the free version is I just wanted the initial entry point price to be as low as possible, so guys like yourself could spend that $265, get it up and running, play with it, and see, hey, it works, and it's worth it to spend the $99 for the Pro software. And what I've done is I put limited functionality of some of the advanced features in the free version. So if you had a touch probe and you wanted to use a touch probe will actually work with the free version of the software. So you could actually hook it up, wire it up just according to one of our schematics, and use our menu-driven software to probe the center of a board, for instance. Mm-hmm. If you had a probe, or do a tool touch-off, that sort of thing. So I've put the facility, even in the free version, for guys to be able to use these features and play with them and understand the value of it. And then hopefully they'd be interested in purchasing the Pro version of the software at that point.
Now, tell us about your software model. Is it a maintenance style thing where you have to pay so much every year or every few months to keep the software running?
No, we for many years with our software, we do issue updates, and we say updates are free from a year from purchase, but we're actually much more generous than that. It usually ends up being about a 3-year cycle. Mm-hmm. And if you want to upgrade when there is an upgrade available, in that 3-year period, you just go to our website and download the software and install it yourself. You don't have to call us and ask for anything. It's just freely available for download. When you have a license, like a Pro license or an Ultimate license, that license will work with the new version of the software. So you don't have to email us for some new numbers or file or anything. It just works. And about every 4 years or so, we actually introduce a significant change in the software, a significant upgrade. And at that point in time, we differentiate it from the old software by upping the rev number. Like right now, we're on version 4 of CNC 12, which will probably be around for at least 3 or 4 years, I would guess. And then at some point, we'll go to version 5. And when we go to version 5, if you have version 4, what we've done in the past is we just ask for a small upgrade fee at that point. And with an Acorn user, it's probably going to be in the $100 range, somewhere around in there would mm-hmm. be my guess, because that's typically what we've done in the past.
Okay. So that kind of answers most of the questions that I can think of that somebody would have about this new board. If someone were interested in taking a look at this, where would they go to see information on this?
If you go to CentroidCNC.com, on the main page, you'll see a picture of an Acorn board kind of in the middle left-hand side. Click on that, and that takes you to the Centroid DIY section of our website. And you'll see a picture of the all-in-one DC and the oak at that point, and click again on the Acorn board, and that brings you to the Acorn page, which you're going to see documentation and imagery of everything that we just described here. And a whole bunch of downloads there where you can download the schematics, the software, the spec manual. And there's a link to a quick start guide page where we've created a series of videos that take you through step by step from unboxing an Acorn board to actually getting motors up and running on the bench, that anybody can just watch that and follow the instructions on the video and away you go. And also our CNC community support forum is super active on the Acorn section of that forum. There's a bunch of great guys on that forum. And it is also monitored by myself and a couple of the other technicians at Centroid. So if you have a question or a comment, please feel free to go to the forum and post there, and you'll get a quick answer to your question.
Mm-hmm. Now, what do you envision as the next step? What do you want to see happen with the Acorn over time?
Well, over time, I would like the things that we're working on is right now there is no facility for an MPG with an Acorn board. You asked me what it couldn't do. Mm-hmm. That's a good answer to that question. We're working right now with a company called HXC, which makes both wired and wireless MPGs. And our programmers, the Centroid programmers, are creating drivers for our software so that those MPGs will work via USB. So you plug in the MPG to a USB port on the CNC PC, mm-hmm. and you will be able to control then your machine tool with a USB. So that's one of the things that's coming out soon that we're working on. We also have a feature that we're adding, the DB25 connector that we mentioned earlier. That the pinouts on that DB25 connector right now on the Acorn board are the Mach 3/Gecko G540 standard pinouts. One of the things we ran into a couple months ago is we had a gentleman with a stepper motor drives that were running Linux CNC. Well, it turns out the Linux CNC folks decided to make their pinouts different than the Mach 3 guys. Mm-hmm. And so that customer had to create a custom flip cable, which, as you can imagine, is fairly tedious to make your own DB25 cable. And because the Linux, the pins 2 and 3 and 4 and 5 and 6 and 7 are flipped. The step and direction signals are flipped. So you've got 8 wires that you got to unsolder and solder back in. Well, we thought there's a better way. So one of the things that we're working on right now is we're working on the ability for our software to define the DB25 pinout, what each one does. Mm-hmm. So we've actually got it running on the bench right now. I have a CNC Linux box, and we use a straight through DB25 cable from the Acorn board to the Linux drivers. And in our software, I can tell it, hey, pin 2 is actually direction, not step, and pin 3 is step. And so I can flip those software-wise, so I don't have to solder and unsolder any wires. So we're working on things like that just to make things better and easier as time goes along here.
Mm-hmm. Now, my only complaint, and we're about to wrap it up here, is not a real complaint because I needed this, but I you remember I mentioned earlier I'm cheap. This requires Windows 10.
Yes, it does.
To run. And so for some people to use this, they will have to get a newer modern level computer. And one with a fairly fast processor.
Yes.
Yeah.
You can buy right now, you can go to Walmart and get an HP touchscreen laptop for $360 that meets the Acorn CNC requirements. It has Windows 10 on it, it has an i3 processor, and it has a touchscreen for $360.
Okay.
So those deals might not always be available, but you know computer technology. It's just getting better and faster and cheaper all along. So I know there's a bunch of guys that have some old PCs collecting dust in the corner with Windows 7 on, and they really wish they could use that. Don't go there. You're going to be much further ahead of the game running a PC that meets the minimum requirements. We can talk a little bit about the minimum requirements if you like. One thing we actually didn't mention that I just thought of here mentioning the touchscreen aspect, that Centroid CNC 12 software is touchscreen compatible. And so if you go to the website and see any of the videos online, you'll see people touching the screen to, do all kinds of things in the software, whether it's just jogging the machine, starting the spindle, loading a program. You can all just touch the screen. Mm-hmm. There's many other ways to control the machine tool as well. You can use the keyboard. Pretty much everything you can do on the screen, you can do on the keyboard. You could also do the same commands with a mouse. And there's we're also USB keyboard compatible. So there's like Xbox controllers can be connected up to it. X keys pads can be connected up to it. So you can create custom keys and buttons for your own specific use. So if there's something on your router that you're always doing over and over again, you can just build a little X keys pad and put the label on it. And then when you mash that button, that's what it does, which is pretty cool. So there's lots of options there. Once you start using the touchscreen, I think you really like it. It's a really neat thing to have on CNC Control.
Yeah, there's several things that we didn't really discuss. Most of it involves the computer and the program. Just as a quick description, on the screen you will see your digital readouts to tell you where you are, a few lines of G-code, and off to the right side you'll have essentially the same types of controls as a pendant, which has jog keys and certain repeatable functions and reset buttons and everything all displayed on the screen, as if it were the control panel on the physical machine itself. Very intuitive.
Yeah, if you take a look at our Centroid M400 CNC Controller, our flagship, and then look at the screenshots of the Acorn CNC Control software, they're almost identical. So we've replicated virtually on the screen the M400 CNC Control in the Acorn CNC 12 software. So all that functionality that you have with hard buttons on the M400, now you have soft buttons that do the same thing and have the same names and the same labels and all that right on the Acorn CNC 12 software, which is pretty slick.
All right, fantastic. Okay, I think we have spent quite a bit of time talking about the Acorn, and I know that you're busy today. I am as well, and we don't want to overwhelm the listeners, but this is exciting to me. A new product that comes out that basically solves a lot of problems for people. And that's the whole point of, talking to you, is finding out about the new technology that's out there that makes it easier for people to get into CNC. And I think that the Acorn board is one of those.
Yeah, we're really excited about it as well, Bill. And I just want to mention as well that Centroid is obviously an American company located in Howard, Pennsylvania, and it's family owned and been in business since 1979. So we're here to stay, and we're devoted to happy customers making parts and running their machine.
Fantastic. We've been talking with Keith McCulloch from Centroid CNC, and again, you can check out their website at Centroid, that's Centroid CNC.com, and I think you'll find it interesting. Thank you so much for taking the time to share your knowledge with our CNC family here, Keith.
Thank you so much, Bill. It was a pleasure talking to you.
I often mention many different types of software during the episodes, and hardware and cutters, and it can get a little confusing. So what I did was I put together a page on my website, cncroutertips.com/resources. And on that page, I list all sorts of resources there, from books to tools to software, all the things that I use that make my CNC experience better and easier. And I hope you'll check it out. So again, it's cncroutertips.com/resources. Now, if you'd like to have your question featured on the air, here's how. Need help? Ask me about your CNC router question on my podcast, the CNC Router Tips Podcast. I'll be glad to help, or try and get you the help you need. I want this podcast to be a fun and personal experience for everyone, and helpful. So let's keep it real and ask sensible questions. Please use common sense and show courtesy to everyone. That way everybody wins. Here are some guidelines to ensure that your question is qualified to be featured on the show. Please keep your questions under 1 minute in length. If it goes a little over that, that's fine, but don't ramble. If you have a website and URL, you're allowed to share it, but only once during the recording. Spammy or disrespectful or deeply private questions will not be considered for the podcast. If you need to ask more than one question, just make each question a separate voicemail. Thank you, everyone, for listening in. I'm your host, Bill Griggs, and I really hope that you have a great day.